All right, welcome to The Explainer. Today we're diving into a really mind-bending new theory about a hidden structure to our universe. It's this idea that the answers to some of the biggest puzzles in physics might actually be hiding in plain sight, all governed by one single fundamental rule. So let's just start with a paradox, a real head-scratcher that's been bugging physicists for more than 100 years. We have the speed of light, which is this universal constant. It never ever changes. And yet the fundamental forces of nature, they have strengths that are all over the map. So how can reality be both perfectly constant and wildly variable at the exact same time? What's going on here? And look, this isn't just some minor little inconsistency we can sweep under the rug. This is a huge, fundamental contradiction right at the very heart of physics. It's like a tale of two completely different behaviors that are supposed to be governing the same universe. And, that's usually a pretty big clue that we're missing a major piece of the puzzle. I mean, this really shows you the sheer scale of the difference we're talking about. On one hand, you've got gravity. It's so weak you can literally overcome the entire planet's pull just by jumping, but its reach is infinite. Then, on the other hand, you have the strong nuclear force. It's unbelievably powerful, but it only works over these teeny tiny distances inside an atom. The difference in their strength isn't just big, it's staggering. So what if we've been looking at this all wrong? What if the difference isn't in the forces themselves, but in the scale at which we happen to be observing them? This new paper proposes a really radical shift in how we think about this. Instead of different rules for each force, what if it's all the same rule, just measured with a different ruler? And this is the core idea, the one the paper calls scale as cause. The argument is that forces only seem to have different strengths because the action, the change, is happening over totally different distances within the actual fabric of reality itself. Okay, so here's the crucial point. The strong force isn't fundamentally stronger than gravity in this model. No, it just acts over an incredibly tiny distance, which makes its effect seem absolutely enormous. Gravity, on the other hand, acts over a much larger distance, so it appears way weaker. It's the same basic process, just playing out on a different-sized field. But, okay, wait a second. This brings us right back to our original mystery. If this absolute structural scale, what the paper calls L, is so critical for the forces, why in the world doesn't it affect the speed of light? Why does light travel at the exact same speed, c, whether it's crossing a galaxy or just a single proton? Well, the paper asks us to completely reimagine how light travels. It suggests it's not some continuous thing moving through space. Instead, you need to think of space as a grid of discrete units. Light moving is more like a sequential update from one unit to the next, kind of like a line of dominoes toppling over one after the other. And this is the solution. It's so clever. The theory proposes that the time it takes for one of those dominoes to fall is directly proportional to its size. So, at the micro level, you've got tiny steps happening incredibly fast. At the macro level, you have huge steps happening more slowly. But the ratio, the distance divided by the time, always cancels out perfectly, giving you the exact same speed of light, c, every single time. So, if reality is made of these discrete units, these little building blocks, does it have a specific structure? The paper says, yes, absolutely. And it proposes a surprisingly specific and, get this, repeating pattern. The key concept here is called structural coalescence. And the idea is that at the most fundamental level, reality has 12 distinct components, or degrees of freedom. You can think of them as independent moving parts. But as you zoom out, these individual parts start to merge their behavior, and they start acting together as one. So try to picture it like this. At the smallest possible level, you have these 12 independent parts. Let's think of them as 12 individual musicians, and they're all playing their own unique melody. But as you start to move farther away from the stage, you stop hearing the individual instruments, right? Their sounds begin to blend together. Their rhythms start to synchronize, and eventually they start to sound like a single, unified instrument. And from a distance, those 12 individual musicians have effectively become one cohesive orchestra. They've coalesced. Now, this isn't a numbers game. It's a structural change, where the behavior of the group completely takes over from the behavior of the individual parts. And here's the kicker. Once that coalescence is complete, the whole pattern repeats itself. That single, unified orchestra, it now becomes just one musician in a new, even larger orchestra of 12. And this repeating cycle of 12 becomes 1, which becomes part of a new 12, is what the paper suggests actually defines the boundaries between the micro and macro worlds. So, okay, that's a really elegant model. But how does this 12-part blueprint actually solve the paradoxes we started with? How does it explain the huge difference in the forces and the absolute constancy of light? Let's just put it all together. The strength of a force, it turns out, depends on that absolute structural scale, L. And as you can see, that scale is just different at the nuclear, atomic, and gravitational levels. A smaller scale means a stronger force. Simple. Meanwhile, the speed of light, c, is just a ratio of that scale, L, to the update time, tau. And because the time also scales perfectly with the distance, L just cancels right out of the equation, leaving c perfectly, beautifully constant across every single level. Now, I know what you might be thinking. This is a beautiful story, a really cool idea. But is it actually science? Well, the authors argue that yes, it is, because this whole structural model makes very concrete, falsifiable predictions. It offers specific ways we could go out and prove the entire theory wrong. And this is what makes it good science, right? The theory can be broken. If we go out and analyze nature and find that the scales form a smooth, continuous line instead of these discrete bands, the theory's wrong. If we somehow discover that force strength and light speed are linked and change together, it's wrong. If that 12-part pattern is nowhere to be found, it's wrong. That testability is what makes this a really powerful scientific proposal. And so this leaves us with a final, really provocative question. Is it actually possible that the unbelievable complexity of our universe, everything from the quantum realm all the way up to the cosmic web, is all governed by a simple, elegant, repeating 12-part rule, just hiding right beneath the surface of everything we see? Well, according to this theory, the answer is a resounding yes.